You've probably heard it before. Chimpanzee DNA is about 98 to 99% identical to ours. So why can't they talk? Why can't they sit down and have a conversation like you and me? The answer isn't what you might think, and it reveals something profound about what actually makes human language possible. Today, we're diving deep into one of biology's most fascinating mysteries, the enormous gap between genetic similarity and linguistic ability. Let's start with the brain itself. A chimpanzee's brain weighs about 380 to 450 grams. Human brains average around 1,300 to 1,400 grams, so we're talking roughly 3 times larger. But here's where it gets interesting. It's not just the size that matters. The overall architecture of both brains is strikingly similar. We have the same major regions, the same lobes, even comparable neural organization in many areas. Yet somehow, only one of us can write poetry, negotiate treaties, or argue about whether a hot dog is a sandwich. The difference lies not in what's there, but in how it's wired and what's been added. The real culprit is something called Broca's area, a region in the left frontal lobe that's absolutely critical for speech production. In humans, Broca's area is enlarged and highly specialized. It's responsible for the motor control needed to articulate words, to string together syntax, and to produce the rapid, precise mouth movements that speech demands. When neuroscientists examine chimpanzee brains, they find that this region exists, but it's much smaller and far less developed. It's like comparing a smartphone to a landline. The basic circuitry is there, but the processing power and specialization are completely different. But wait, there's more. Even if a chimpanzee somehow had an enlarged Broca's area, their anatomy still wouldn't cooperate. The human larynx, or voice box, is positioned lower in the throat than in other primates. This unique positioning gives us greater control over the sounds we can produce and the precision with which we can produce them. Chimpanzees, by contrast, have a larynx positioned much higher. Combined with their different throat structure, tongue shape, and overall vocal apparatus, they're simply not built to make the wide range of sounds that human speech requires. Their vocal cords can produce grunts, screams, and hoots, communication, yes, but not language as we know it. Here's something that might surprise you. Researchers have actually tried to teach chimpanzees spoken language, and it was a spectacular failure. In the 1930s, Winthrop and Eula Kellogg raised a young chimp named Gua alongside their own son in a controlled study. After months of intensive exposure and training, Gua produced nothing resembling human speech, just the occasional strained imitation that sounded nothing like actual words. The conclusion was obvious. Chimpanzees lack the neural and anatomical machinery for speech. But this didn't stop scientists from asking a different question. Could chimps learn language in other ways? Enter Washoe, a female chimpanzee born in 1965 who became one of the most famous apes in history. In the 1960s and 1970s, researchers at the University of Nevada taught Washoe American Sign Language (ASL). And here's where things got genuinely remarkable. Washoe learned to produce over 250 signs. She could ask for things, name objects, even combine signs in ways that suggested rudimentary syntax. When her caretakers signed to her, she understood. She signed back. This seemed to prove that chimpanzees could learn language, they just couldn't speak it. But the story is more nuanced than that. The controversy around Washoe and similar experiments like Nim Chimpsky, a chimp taught ASL in the 1970s, reveals the complexity of defining language itself. Critics pointed out that while Washoe could produce signs, she wasn't really creating grammar or complex sentences. She was making associations between signs and objects or actions, kind of like a very intelligent parrot learning to say cracker. The signs weren't arranged with human-like syntax. There was no evidence of abstract concepts or the ability to discuss things not immediately present. It's a profound difference between learning symbols and understanding language as a system for generating infinite meanings from finite parts. So what's actually missing? Scientists point to something called theory of mind, the ability to understand that others have thoughts, beliefs, and knowledge different from your own. Humans use language not just to communicate immediate needs, but to share thoughts, tell stories, ask hypothetical questions, and understand abstract concepts. Chimpanzees, while incredibly intelligent, show limited evidence of this kind of mental modeling. They don't ask why. They don't wonder about things they haven't seen. Language, as humans use it, requires this cognitive framework, this ability to represent ideas that exist only in imagination. Without that foundation, learning to manipulate symbols becomes just impressive imitation, not true linguistic ability. Here's the mind-bending part. Some researchers argue that the capacity for language, true, recursive, infinite meaning-generating language emerged very recently in human evolution. We're talking within the last 100,000 years, maybe even more recently. Before that, our ancestors may have had all the brain hardware we have now, but without the crucial software update that enables language. It's possible that some small genetic change, a mutation affecting gene expression in the developing brain, changes to neural connectivity, or new patterns of hemispheric specialization suddenly made language possible. This wasn't a gradual improvement, it might have been a flip of a switch. And because that switch exists only in humans, no amount of training can give it to chimpanzees. What's extraordinary is that this tiny genetic and neurological difference, this unique human capability, has created the entire world we live in. Language is how we build civilization, pass down knowledge, imagine futures, and connect across vast distances and time. A chimpanzee might be 98% genetically identical to us, might share most of our brain structures, might even learn to recognize and produce hundreds of symbols. But without the neural substrate for true language, they exist in a fundamentally different cognitive universe. They're brilliant tool users, complex social animals, and in many ways our closest living relatives. But they can never tell us what they are thinking in the way that we can tell each other. The deepest lesson here isn't really about chimpanzees at all, it's about us. Their inability to speak reveals that human language is something extraordinarily special, something that can't be explained by brain size, genetic similarity, or intelligence alone. It's a uniquely human innovation, a tool so powerful that it's become inseparable from what it means to be human. We are the only creatures on this planet capable of discussing why we're capable of discussing. That circularity, that ability to think about thinking and communicate about communication, is locked behind a neurological door that only humans can open. And understanding why that door exists and why other species can't open it helps us appreciate just how remarkable our ability to speak actually is. The gap between genetic similarity and linguistic ability is one of nature's most humbling reminders that we are, despite our kinship with other primates, genuinely unique in our capacity for language. If you enjoyed this deep dive into the science of speech and what makes human communication so special, smash the like button and subscribe so you never miss a video like this one.